Alright students, so here is our problem. A particle is moving along a straight path at a constant velocity v. Now we are given three observations about its motion. First, at t is equal to 0, the particle is somewhere between x equal to 10 meters and x equal to 12 meters. Second is, during the fourth second, that means between t is equal to 3 seconds and t is equal to 4 seconds, the particle crosses the point x equal to 22 meters. And third, at t equal to 12 seconds, the particle is located somewhere between x equal to 55 meters and x equal to 60 meters. Based on all these three constants, we have to find out during what time interval will the particle arrive at x equal to 88 meters. So let's solve it. Okay, so let us set up the problem. Consider the initial position at t is equals to 0 is x naught and the particle is moving with constant velocity v. Then from the equation of motion we get x is equal to x naught plus v into t. Since the particle is moving in positive x direction, so because the position is clearly increasing, we can take v is greater than 0. Now our step 1. This is the first constant which indicates the initial position. And here at t is equal to 0, the particle lies between 10 meter and 12 meter. That is, the initial position x naught is greater than or equal to 10 and it is also less than equal to 12. So the range of x naught would be in between 10 meter to 12 meter. Now here is our step 2. This indicates the second constant, which is when the particle reaches x is equal to 22 meter. In this case, we can write that 22 is equal to x naught plus v into tau. Here, tau is the time which is between 3 second to 4 second. That is, it indicates the fourth second. So we can write from the equation that tau is equal to 22 minus x naught upon v. That is, 22 minus x naught upon v is greater than or equal to 3 and also it is less than equal to 4. Now our step 3, and this is the third constant. It means this constant is at t is equal to 12 seconds, and at this particular time the position lies between 55 meter and 60 meter. It means we can write that x naught plus 12 into v is greater than or equal to 55 and also this is less than and or equal to 60. Now our step 4. Here we calculate the time when the particle reaches at x is equal to 88 meter. It means we can write it as 88 is equal to x naught plus v into t. That is, t is equal to 88 minus x naught upon v. And this is our equation 1. Now, what do we need? We need the minimum possible time and the maximum possible time to reach x, which is equal to 88 meters. That means we have to find maximum and minimum allowed speed respectively, and those allowed speed must satisfy all the three conditions or constraints which is given above. Now we come our step 5. For the maximum possible speed, we use our second constant, and if we take 22 minus x naught upon v is greater than equal to 3, it means we get v is less than or equal to 22 minus x naught upon 3. And if we take 22 minus x naught upon v is less than or equal to 4, and from this we get v is greater than or equal to 22 minus x naught upon 4. Now, to maximize v, the numerator should be maximum, and for this x naught must be minimum. So from the first constant we get x naught minimum is equal to 10, and from the condition v is less than or equal to 22 minus x naught upon 3, we get, after putting the value of x naught is equal to 10, we get the maximum value of v is equal to 4 meter per second. Now if we check it with constant 3, we get x is equal to 10 plus 12 into 4, that is 58 meter, which lies between 55 meter to 60 meter, and this follows our third constant. It means this condition is valid. But if we put x naught minimum is equal to 10, in the condition v is greater than equal to 22 minus 10 upon 4, and we get the minimum value of v is equal to 3 meter per second. But since here we need only the maximum value of v, it means this condition, that is v is greater than equal to 22 minus 10 upon 4, can easily be discarded. So we can say that the earliest time to reach x is equal to 88 meter from equation 1 is t is equal to 88 minus 10 upon 4, that is 19.5 second. And this 19.5 second is the least value of the boundary condition to reach x is equal to 88 meter. And we call it equation 2. Now an important note. For the maximum arrival time, if we apply the same method and use x naught is equal to 12 meter in the second constant for the both boundary conditions of v and check it out with the third constant, we get the both value of x which do not lie between 55 meter and 60 meter. That is, both are invalid. Here, as an exercise, we leave it to the students to verify. So, in this case, we use a method which is called Combined Inequality Method. Now we come at the step 6. Since the crossing at the position 22 meter happens at time tau, where tau lies between 3 second to 4 second, and then using the equation 22 is equal to x naught plus v into tau, and it means x naught is equal to 22 minus v into tau, and by using the third constant, that is at t is equal to 12 second, we get x naught plus 12v lies between 55 meter and 60 meter, and after substituting x naught, we get 22 minus v into tau plus 12 into v lies between 55 meter and 60 meter, that is, v lie between 33 upon 12 minus tau and 38 upon 12 minus tau, and this is our equation 3. Now here we come on step 7, in which we calculate the maximum arrival time by using the relation t is equal to 88 minus x naught upon v. And here if we substitute x naught is equal to 22 minus v into tau, we get t is equal to 66 upon v plus tau. And if we want to maximize or maximum value of t, we have to use the minimum allowed value of v from equation 3, that is v is equal to 33 upon 12 minus tau. Then we get t t is equal to 66 into 12 minus tau upon 33 plus tau. It means t is equal to 24 minus tau. Now we know that tau lies between 3 seconds to 4 seconds. So for maximum t, we have to put tau is equal to 3 seconds. That is t is equal to 21 seconds, and this is our equation 4. Now from equation 2 and 4, we can conclude that t lies between 19.5 seconds to 21 seconds. So we get our final answer, and this answer is the particle reaches x is equal to 88 meter between 19.5 seconds and 21 seconds. Thank you.